the goal of this lecture is really to finish how to write a paper with an example and to give you some concrete evidence of what it means to write a paper. But before doing that, I want to kind of go back to number 7, to the last 2 points, because last time the PC was running out of battery, so I could not finish it. So let me just concentrate on the process. I really want to spend some time here because I think it's really crucial. So writing a paper is like an iterative process. I mean, like similar to what in engineering is called, in software engineering is called the spiral approach, which means you need to revise a paper many times. And revising many times until you find the right message. And in these revisions, you really need to make sure that you're converging. I mean, revisions does not mean that you rewrite everything. If you rewrite everything, at a certain point in the process, this means that there's something majorly wrong going on. So it should be like a process by which continuously you focus more and more on the details, and you make sure that the overall structure of the paper converges and gives the main message as given by the title of the paper. So to go on, pretty much, and going through this graph, this picture, you see like the key point is really analyzing the readers. Analyzing the readers is something that most of you forget all the time. Who are the readers? The readers could be me. The readers could be your colleague at the university if you needed to explain something to them. The readers could be the reviewers. The readers could be the people which read your paper once accepted. But you must be very, very clear what are your readers, because once you have the readers, you really can only, for those readers, really understand what is what I call the unique selling proposition, which is what is the main message of your paper. And it's very clear that the only way to understand the unique selling proposition of your paper is just to try to do it. As I said many times, the analysis at the beginning does not get you any close to that. The analysis gets you to understanding better what you're doing, but not to the point where you can communicate what you've done. And once you've done the analysis of the readers, then you have to defining goals. Defining goals means one paper, one message. I already give this. And this again is strongly depending on the readers. And then you do the structuring paper, the coarse-grained. But you see here there is a loop. Coarse-grained, as I said in the past, is really, and I'm going to go through the example now, it's going to be pretty much the index plus something more that I'm going to give. And you keep iterating. Usually the coarse-grained structure is actually kind of easy. It's kind of easy. It is usually what I tell you what to do. But then the next time you do the fine-grained. I already explained last lecture what the fine-grained is, but the fine-grained is much, much harder. If the bridge say the proof is the pudding, then the pudding the fine-grained structure. In the end, you must really have an overall picture. And see, there is something that students do not understand. When you write a paper, and for instance, you're writing something in session number 4, page 7, when you write that one sentence, you must have very clear everything written from page 1 to page 7, and from page 7 to the last page of the paper. Because ultimately the paper is just an explanation, it's just an argumentation. And you just cannot throw in, as most of you done at the beginning, sentences more as random. The reader is a king, and what you put in one part is really must be fit the overall structure. So fine-grained structure is where most people suffer. And we're most of the time years. And as you see, you can really go back from fine-grained to the coarse-grained to the defining goals. The defining goals can even be changing the title, because as I told you already, the title is a key message. And then finally, after some time, you assume the paper is finished. You go to the blue line here, and then you ask feedback. Now, how you do? Either you submit when you run out of time, as you usually do, you get feedback. And then sometimes the feedback is disruptive. Or you go around and give talks, and you get disrupted. They can just tell you just forgot everything. And then you get a feedback from the peer review, usually when you submit. And I think this, in most cases, is very good. It's really good because the main message you get from the reviews is really whether what you wrote fits that community, whether you made yourself understood for their community. I already told you many times that for the same real world problem, each community has its own perspective. Then each community has its own notion of the state of the art. Each community has its own like best conferences, best papers, and so on and so forth. The feedback very clearly highlight you this, and you can get in many ways. For instance, they can tell you you forgot to cite this paper, and when you get something, if it becomes very negative, it means rejection. Because they tell you you don't really know the state of the art, that's a rejection. Or sometimes they tell you, oh, well, you should submit this paper, it's marginal but important, and so on. And it is one type of feedback. And another type of feedback, usually they just tell you what they don't understand or what they understand. And it is something they don't understand. The question should make clear is whether what they don't understand is because maybe you don't fit the community properly and the state of the art. And so this is clearly the loop, and then you get to the paper publishing. When the paper is published, then you get more loop, more feedback. How do you get feedback from the paper publishing? You get feedback from citations. You get feedback because sometimes people send you email and ask clarification, ask papers, but the obvious feedback you get for paper publishing is citations, which is people tell you how they use your work. In some cases, they even write a paper to tell you that you're wrong. That is when your paper is important enough, and so on. So there are papers to contradict other papers, but it's pretty radical. To me, happened only 2 papers in my life. So that happens. But anyhow, this is the process, and you must take it very seriously. And by the way, there is no shortcuts. I mean, if you don't do the analysis of the readers, if you don't come a good cause, if you don't do a good coarse-grained, if you don't do a good fine-grained structure, your paper is going to be not good. So you have to learn how to do it. And then, of course, once you learn the methodology, it will be up to you because every paper is a different paper. Every paper is written different by different authors. So once you understand the methodology, you are free to interpret these index, this way of working. But what is interesting in my experience that most of you, they just say, oh, yes, I understood, very nice lecture, blah, blah, blah. And then they come to me, they just do something random. And they just forget about the methodology. And they explain to me for hours why this methodology doesn't apply to them, which means exactly they're not doing their homework. So all of this is a way of thinking, a way of learning how to think. And you have to need to learn the methodology as part of the PhD. And as part of the process before moving on, I mean, like, there is an issue of style. I mean, you cannot make mistakes in English. You just cannot. And the third mistake in English that I see, to me, the paper is over. You cannot write English in your own way. I mean, just look around for papers published anywhere and look for the mistakes in those papers. If most of the papers don't have mistakes, I don't see any reason why you should write papers with English mistakes that be acceptable. The drawings must be very clear. I mean, sometimes you have a problem with space, and there are people shrink the images. And of course, you do not read what is written in the images. That's unacceptable. Sometimes there are like a notation. There is an issue of aesthetics, which is very important. and so on. So that's what I'm saying. Look at the other papers that you read. Look at the papers you read. Look at them, and you see how nice they are, how nicely packaged they are. And by the way, that did not come for free. And there is no reason why your paper should be worse. So when you write, if you do not go to know good in English, that's your problem. You have to fix it. As simple as that. This is why we teach English in our PhD. Watch TV. Stop talking your native language. I mean, but if talking your native language is not good enough, it means prevents from learning English, writing in English, and talking in English, that's a major problem for you. You can't spend all your life as a PhD translating all the time. And it's clear that in the international level now at the moment, the official language for interactions is English. Maybe in due time it will become Chinese, but I think we're still far from this. So for the moment, you have to learn English. So this is pretty much it for what I wanted to say concerning this part. Now let me just go and take an example, just to give you an example. So this is a paper we wrote with Wani and many others. I think Wani is online. It's a paper which I think will have a good success. It will be cited. It's growing, but it will take time, but it will grow. So this is a paper which was written and published in the ACM UbiComp. UbiComp is one of the top conferences in pervasive ubiquitous computing. And actually, it is actually a journal paper, which is they write, they make you submit to the journal, and then you present to the conference. And a lot of conferences now, they're going in this modality, a lot of colleges and communities. This community is a community which pretty much is a spin-off, which is at the intersection between HCI, human-computer interaction, and pervasive systems. So, and of course, notice that I'm telling you about the conference because I'm just telling you the motivations which led to this title, which led to submit this paper here, right? So this community is very interesting, the human factors in humans, in human behavior. Some like me would argue that the best conference in this sector, I think the impact factor of this is like 5 or 6, I don't remember. Anyhow, so they are in the human factors people try to prefer long titles. Like if you go to a standard AI, EGK, more technological, then they prefer short titles. It's just a matter of, and I'm saying this because when you submit, you need to know this. Otherwise, you have no choice and no option in getting the paper accepted. A paper published in UbiComp here will have to focus on the human factors. You have to focus on the experiments. You have to focus on the impact on people and the impact of technology on people and of people on technology. A paper submitted to EGK or AAAI or whenever AI conference, this issue of people is not important. I mean, they're just a good motivation, a good way to run the evaluations, but they are not the target. Like in a EGK or AAAI conference, like people are the means to show the technology, but the goal is the technology. It will become just opposite. In UbiComp, the goal is people and how people react to technology, and technology is the means. So this means that in this part, the motivational part is going to be much stronger. The technological part is going to be less important. Of course, important is the top conference, the top engineering conference, but less important in AAAI or EGK, and then the evaluation here is going to be much more important and must be more real world. So with this in mind, we can go to the paper. And then given the paper, what I'm going to go do now, I'm going to go through the paper in 2 passes. First, I will go for level 1, the coarse-grained structure, and then we go with level 2, which is the fine-grained structure. And to mark the distinction, I just took the 2 colors and I made so that to make them distinct. And they are actually, as you remember from my previous slide, they're one after the other, which is a It's not that, and of course, one after the other in a spiral approach where you may have to iterate multiple times. Okay, you read this paper, you see there is a very long title, Fixing Mislabeling by Human Annotators by conflict resolution and the exploitation of prior knowledge. So here, fixing mass mislabeling by human annotation. This is the problem. Mislabeling of human annotation is a problem. The fixing is kind of gives you the introduction to the second part, which is the solution space, which is conflict resolution and the exploitation of prior knowledge. Of course, here in this paper, we did have in mind something specific, a domain. Remember the titles, I told you that in the title there are usually 3 domains. And the domains is like, could be medicine, could be anything. Why did not put the domain here? Because in this conference, the domain is pretty obvious, is human behavior. So by submitting here, if we just apply just to human behavior in general, if your result is general enough, at least you're not exploiting any domain knowledge like you could do like in health, then you don't put the domain. If you wrote a similar paper in Giunchiglia, most likely you'd have to put activity recognition somewhere, because there, since Giunchiglia is much broader on the technology side, you have to consider and make more explicit the technology part. Anyhow, now you read the abstract, and the abstract I put is the first level grain structure. It doesn't mean that you write the abstract at the beginning, but if you read, you just see that for the paper that the 5-word, the 4-word promise statements become 2 lines, that the 6-word solutions become 3 lines, and that the evaluation, the validation, which is not in the title, has become 2 lines. Okay? And this is a coarse grain structure, even if you don't write at the beginning, because as I said, this is exactly what people read at the beginning. So the title and the abstract are fundamental. You have to really get the right message there. And you go to the introduction. The introduction here is a coarse grain structure. And if you go into it, you will see the 3 parts: the problem, solution, context. In this part, the context is somewhat squeezed in as a few lines where the problem is okay. This part of your creativity. And then there is the solution space, and then here there is the solution, but there's a contribution, the structure of the paper. It's there. So usually, sometimes when you write a paper, I sometimes write the introduction in. When I write the introduction, sometimes I write in pieces and bits, which is sometimes I write the bullet points at the beginning, maybe in the middle, anytime I think I have a message, but ultimately, as I said, the introduction and the title are the things which need to be written last. And by the way, when you do this, you really have to do what I'm saying. I mean, what I'm telling you, what I'm suggesting you, when you write a paper, when you think you're done, you just take the paper, you print it out, and you use a pen. You just do exactly what I do. I've done here, right? It's not that I've done, they don't do it, because no, I mean, even in my experience, sometimes you don't get it right. As I said last time, getting this thing right, it does not come easy, even with a lot of experience like me. So being in full control of the process is fundamental. This using the pen to mark, give you feedback, to give to yourself, it's important. Sometimes some of you come to me and they ask for feedback, and sometimes I print out the paper and I give them this kind of feedback using the pen. Why? Because sometimes it's okay, and why sometimes you need to move the material around. Now, then you have the related work. Now, the related work again, the related work is part 2. The title is red, but is red means the first part, but the related work usually is FineGrain Structure. But you see again in this related work, you just have three paragraphs. So paragraph number 1 is social science and psychology, state-of-the-art where, which is the second one is a domain. We said that we're doing the students because there was a lot of work. Paragraph number 3, the technological problem, right? This is an HCI, Human-Computer Interaction Conference. We're not a technology conference. So first you concentrate on the problem. And since we want to say that we want to ground our work in the real problem, we just cite social sciences. Then we say, okay, by the way, we are our technologies in general, but we are using students and a lot of work, we need to know this work. And then we go to the technology. Of course, so the point I'm telling you that the FineGrain structure, and do remember that the FineGrain structure, it comes in the second round from the what I said at the beginning. Now I'm going through sequentially through it. But the FineGrain structure, we tell you that the FineGrain structure for the same work in Giunchiglia, and I'm just taking Giunchiglia as a standard AI conference, and in UbiComp is different. Most likely in Giunchiglia, you could have written the same argument for sure. However, the number 3, like the technology part, is going to be first in the related work. So you see, the order is important. But here we just do like this because they want first the social, and the social study is very good for UbiComp because they are the HCI people. They have a lot of user study. They come from the CHI conference with a very lot of work in psychology, social sciences, and so on. And this, I think, is crucial. So what would you write, however? But this is the end, right? So how would you write this part? In the first part, by doing the coarse-grained structure, you will not be writing any of the related work. But when you do when you do the fine-grained structure, the first version of the related work will be bullet point, social sciences related work. Second bullet point, student experiments. Third bullet point, technology related work. And dude, I'm asking you that most of you fail all the time. When I tell you the fine-grained structure, I do not want text. I just want 3 bullet points. Social sciences related work, experiment domain work, related work, technology related work, and at most in the fine-grained structure, you just put citations, or maybe the citation you want to remember. So the fine-grained structure or the related work, the first version is just 3 lines and a bunch of citations. It's not what I usually get, which is like half a sentence, more or less random, written with no understanding of which is the structure of the argumentation. And as you think, as I was telling you, I think you see the argumentation. The argumentation, we have HCI, we have UbiComp, they're interested in people. We start from people. People meant as the domains we study, people meant as the students, and then in the end I do the technology. As I said, Giunchiglia will be just opposite. Maybe in Giunchiglia, the social scientist, they will not even put. I mean, the students for sure will not even put. The student you just put in the validation. Just say we are validating on students most likely. And then you move the first section after where is this? All right. So, and by the way, and then there is another related work which is like more technology, which is participatory sensing and mobile crowd sensing. Good. Now in this conference, though, the relative was one more. In this conference, always, if you look at the structure of the paper, since they come from an HCI community, the methodology is fundamental. The methodology, how we do the experiment. Like in Giunchiglia, section number 3, methodology would make no sense. But if you look in UbiComp, like 70%, 50%, 80%, lot of papers are about the method. And that's the way to do it. Does it mean that all the paper have to have method as a title of section number 3? Of course not. But you have to be very clear that in this community is what they want. Okay? Actually, I don't like a method as number 3, but it doesn't matter. This is my own style. And now here, now first of all, notice that there is a picture here, right? The picture is coarse-grained structure. It's red, it's not blue. Which is, when you write a paper, you have, why? Because as they say, one picture, 1,000 words. The coarse-grained structure is the index plus the main building blocks are where you put the main graphs or the main tables, the main pictures. So I don't remember now, but I'm pretty sure if you ask Wani, that Wani did this picture very, very early in the paper writing. And if I remember well, 1 year to rewrite, this picture sounds so nice and obvious. I think Rani rewrote it like 20 times. Well, you can ask her, but I'm sure I remember that was very non-trivial. The first version was much worse. It's not that you come with a random picture, you're happy. No, this picture is nice. We took a lot of stuff. And each of the symbols here has a meaning, right? The dash lines mean the device. We split the sensors from the user, even if they are on the same device. Why? Because we put a word. We wanted to say in the top, uniting them, the word generates both, but then the device gets input from the sensors and the people. And we put them in opposite sides to make clear that the two flows were independent. Then we wanted a prediction. By prediction, we said that we wanted to have like a mixing prediction. So we just said F1, Fn, because ultimately I think we used like a random forest. We wanted to make an emphasis there, right? We could have just put a single box, but in that time we wanted to make this clear. And then we had like the SDGK, schematic knowledge, ground knowledge, because we want to have an emphasis. So all these items in the picture took us days, not days as many hours, but days as elapsed time, maybe 1 week to get it right. So it's not that you just write the first picture that comes to your mind. Of course, you write the first picture that comes to my mind, but then you have to refine it. And then you go to the next one. Okay, good. Now we go into moving to the FineGrain structure. You see, first of all, let me go to the end with the coarse grain structure. So we have introduction, then we have related work, and by the way, you have related work at the beginning, which is very bad from my point of view, but this is how this community calls it, it's not state of the art. Then you do like number 3, the method, and then since the method usually they have this session, then you're in these papers we have a session 3, which is usually long, to me too long, and then what you do, you just put since you want to give structure, you give like 3.1 the argumentation, like 3.1 the reference architecture, 3.2 the main algorithm, 3.3 there is all coarse grain structure, 3.3 the conflict management algorithm. And this means that as coarse grain structure, when we write this with this index, we have decided that the main solution space of the approach is divided in 3 main components. Of course, and we have the 3 main components and subsessions. Why? Because this is what this community wants. If you write in Giunchiglia, most likely these will be like a level 1 and not level 2 indexes. As I told you before, the level of indexing is fundamental. Something which is 1 level down, the 2nd level or 3rd level is less important. By this community, the method is so important that the component of the method go to level 2, which I think it makes no sense, but it doesn't matter. If I want to publish to this community, this is what we have to do. And again, not necessarily, but it makes it easier. So basically what we said here, the coarse grain structure. The coarse grain structure said, okay, we have a main algorithm, we have a methodology, we just play around with one picture, and then we explain this 3 main picture. We are going to 3 arguments. The main architecture, session 3.1, which is actually explanation of the figure, and then 3.2 and 3.3, the 2 main machine learning algorithms. And in fact, you see, by the way, the algorithm is in there, and again, the algorithm is again coarse grain structure. And then 3.3, the algorithm is there, it again is coarse grain structure. At this time, in this community, you have the solution. What is the next one? Is experiment. And the experiment, of course, the way they want these papers, first you have the data collection, 4.1. And then data processing setup, 4.2, still coarse grain structure. And then here in this paper, since we want to give a lot of emphasis, we separated the experiment from the evaluation. Sometimes you may have experiment evaluation together, but these, since we described a lot of that was the first time we were doing experiments, we gave the experiment a first level citizenship, level 4, session number 4, level 1, which means that we did the evaluation. Why? Because we just described the experiment, which was then used, those data were used many times. And then you have evaluation, results and evaluation. And the result evaluation, of course, you go by experiment. Here, you can have 5.1, no prior knowledge, with prior knowledge, objective versus subjective labeling, variability of users, I forgot, but that we read. And future learning. So basically, you see, we have, and then a discussion and future work in the end. So you see here in the evaluation, we just have one session per type of evaluation. Sometimes, but this is a long paper, 24 pages. In shorter papers, you don't have so many. But UbiComp allows very long papers because it's a journal paper. Then your discussion, then your acknowledgements. Acknowledgement can go in two places, at the end of the paper or as a footnote to the text, up to you, you decide. And then you have the references. And of course, the reference is pretty much obvious. So you see, the way to write with this paper will be that pretty much in the first version of the course-grain structure, you get the index, and the index in this way is pretty obvious, like state-of-the-art related work, method, like experiment, evaluation, conclusion. But then the key part in the computer in a conference like this is the subsessions, in particular the method part and in the evaluation part. And then there is a picture. Does this mean that at the beginning, when you start writing the paper like this, you already have all the 4 or 5 sessions in the experiments evaluation? Of course not. When we started, we had in mind a couple of them. When we started, we only had with or without prior knowledge. When we started the first version of the paper, the course-grain structure had like, we didn't have a objective and subjective labeling, if I remember well, but we have 5.1 and 5.2. But why so? Because but that was good enough to get started. So we had some kind of tentative course-grain, was not final, but was robust enough to start writing. Then we wrote the architecture, and then I remember, Andrea, we wrote the algorithms, we plugged them in, and then you see architecture and algorithms, they really give you a lot of help because they have to explain them. Some of you put a picture and algorithm, they don't describe it. So they think that there are two cases. Either your algorithm is ridiculous, which means you just look at it, you understand, but this means I don't see how you can get the paper accepted, or your paper, your algorithm, or your picture is something interesting, in that case you have to explain. Some of you just plug it in and then don't explain. That's really awful. I mean, it really minimizes the probability of getting the paper accepted. And also, this is why the algorithms like this, and a picture like this, like the one at the beginning, this one, are coarse-grained structure of the paper. Why? Because they really, I mean, you have to explain them. And the explanation of the algorithm and the explanation of the picture gives a novice way to structure what to say. I mean, like you have just to make it life easier to the reader. So you say the reader, look at the black box on the right. We call it word in this way. We call it user in this way. We write pred in this way, and we see that later on. And like here, so like in the algorithms, you see there are lines here on the left. Did you notice 1, 2, 3, there are numbers. 1, 2, 3, 4, why? Because you say in line 13, we do this. In line 16, we do this. You have to make it easier for the reader to understand. Without numbering, it would be much more complicated to make it clear to the reader. So to conclude, usually we start with the course-grained structure of the paper. That will have to be strongly influenced by the conference where you submit. But pretty much the course-grained structure of the paper should give you some kind of overall picture of what is going to be the overall argumentation. Not complete, not right. As I told you in this version at the beginning, we did not have so many subsessions in the end. And but clearly, since the beginning, the first thing we wrote were the algorithms and and the architecture, because we didn't know that the main argument of the paper was around these notions. And of course, we wrote in the evaluation part the two main evaluations, which were the ones which actually justified, motivated the work by 1E. Then I believe, I'm sure it was like this, if I remember correctly. Then later on, we did more evaluations. It's not that at the beginning we had these evaluations, but we did them because we thought they would make the paper stronger. This is also why it takes time to write papers, because sometimes while doing the paper, you do the synthesis, you do realize that for doing the synthesis, you need to do some more experiments. But now this for me kind of gives an example of the level 1. But now I want to go to level 2. Let's go to the fine-grained structure. So here is interesting, right? What I read from you. So first of all, I already told you that some of you, I mean, let me just say it this way. The reader must be helped. So anytime, I already said this, but this is a concrete example. Anytime you can, just use the bullet points. You see here the bullet points on the left, and notice that because this helps the reader. And notice how I wrote that. A reference architecture described in section 3.1, first line. Second line, the main SS manual algorithm described in section 3.2. Number 3, the complete manual algorithm described in section 3.3. Do you think that 3.1, 3.2, 3.3 was by random? No, that's exactly what I do all the time. So here there are two things. Number 1, we used bullet points to do this. Number 2, they use not only to the bullet points, but we use a bullet point to introduce the structure of the session. Why so? Because this session, because of this community, has to be very long. If you have 5 subsessions, the reader will get lost. How do you pretend the reader to remember 6 subsessions out of 10-page session number 3? So here there are 2 messages. Number 1, use itemize to make it easier. Number 3, when you have something which goes through argumentations below, just put an itemize saying, I'm organizing this, I'm going to say this, I'm going to say this, so that the reader will understand at the beginning of session number 3 where you're getting. Suppose that you wrote this paper without these 3 itemized, without these 3 bullet points. The reader will start the session number 3 having no idea what happens next. This will give a major problem for you understanding the big picture. And some of you, most of you, at the beginning, they don't do this, but it's fundamental. Anytime you have to go through arguments, and you have to describe the components, then you have to put somewhere the overall picture. And by the way, what I'm telling you about the overall picture, the subcomponents, the sub-goals, the sub-solutions is general. Because as I told you at the beginning, it's general in the sense that must be applied always. Remember I told you 1 paper, 1 message at the beginning. But then 1 paper, 1 message. I gave you the example. The problem you are solving is how to make a tomato sauce. Okay. But then you have to say, to make tomato sauce, you have to buy the tomatoes, you have to fry the garlic, you have to put olive. Okay. Each of them is a sub problem because they have to decide how to buy the tomato. You have to decide how to fry garlic and so on. So each of them is a sub problem. So this technique of organizing a session in bullet points, where is exactly the key methodology that you should always use, at least until you're experienced enough to have the freedom to decide yourself. It's a standard method for structuring your problem in sub-problems. For structuring your solution in sub-solutions. In your qualifying, always, I tell you, though at the beginning of the qualifying or the problem statement, give the sub-problems. You understand that at the fine-grained structure, if you do something like the fine-grained structure, pretty much at the fine-grained structure at the beginning, you have already articulated when the reader reads the coarse-grained structure, and really helps the user to keep the big picture, because you have to make it easier for the user to keep the big picture. Okay? And you see this issue of using the bullet points I use all the time. sometimes you have 3 components and then you write the 3 components in the text. No. I have 3 components. You read here at the bottom. From figure out, the machine consists of 3 components: SMML algorithm, the predictor, and then the predictor was rather complicated. The knowledge component was complicated. Then we wrote some subtraction. So with A, B, C, we have a level 3 nesting. It is okay. I think I go actually too much from my point of view, but anyway, I wrote it, so I can't complain. And then you see, by the way, this is my own technique. Anytime I do something, always at the end I put the observations, because I say, first of all, I tell you I tell you how to organize, and then I use itemize as much as possible. But usually my own style, I put observations at the end. Why? Because observations are not needed to understand the main algorithm, but they're good for you to have some kind of critical thinking. And then if you go into the FineGrain structures, I've already told the bullet points. You see here with the bullet points have 3 sub-items, but pretty much in terms of FineGrain structure, what do you have here? The one here of the 3 bullet points and the introduction to the entire subsessions. Then the subsession here, if you go here to 3.1, you have if you read on the right, it describes figure 1. Then go below, use figure 1 to describe the approach. When you go do this, while you do this, we use another itemize. The itemize helps us a lot, gives us structure. So the reader will help us. And then observations. So you see 3.1, so section 3, what's this section 3? Section 3 is the introduction to the 3 subsessions and the 3 subsessions. What is 3.1? 3.1, you describe figure 1, which you put at the beginning. Use figure 1 to motivate the approach, and then you have a bullet point for the approach, and then you have the observations at the end, and you're done. It's very clear, it's very linear. The reader will understand. I don't know whether it's very clear, but anyhow, paper was accepted. What can I say? Right, so then you go on, and then again here, we go. By the way, something else. Some of you put equations and formulas in text. That's just awful. Equations usually have structural meaning. A structural meaning means that either those equations mean nothing, or they mean something. They need to explain them, and they give a lot of structure, and they are important. Most of our work is in equations or in processes. So the equations, like pictures, must be made in evidence, and they use numbering because you want to mention them, make it easy. And of course, here what you do, you have the equation, and then you explain the equation, and then you go on. And you see, basically here in this second one, we just use equations to organize, use equations just to give the fine structure of the paper. In this case, the structure of the paper was easy because equations, definitions, gave us the structure of the session. Sometimes you don't have that, but if you have them, that's perfect. But as you see, we do not have a page full of text. In the previous session, I had itemized, I'm using equations, but the structure, the text is organized, it's structured. The conflict manager algorithm, again, we are just using the algorithm, and therefore, if you read this, you see like 3.3, algorithm number 2, if you read the first line, algorithm 2 shows a solve conflict procedure. We introduce. And then we have like a labeling conflict arises, and then we use the technique. To do this, we explain the labeling conflict. Most likely there is a labeling conflict. You see like a section in line number 6. As if conflict, we explain the algorithm. And then we explain the update procedure. You see, update the last paragraph, and then you update in line 13 and 14. Clearly the algorithm, once you have it, is wonderful because it allows you to structure the session. Experiment already, we already split it at the FineGrain structure, but then again, we want, for our experiment, we configure the application as follows. And again, we use the itemize, right? 3 items. Then we give a table. And then we do the scribe situation. Here, what I mean here, that personally, a posteriori, maybe the last paragraph should be in a single paragraph, but doesn't matter. I hate paragraph with 3 lines. But doesn't matter. You see, pretty much the data collection is an introduction, 3 bullet points, a table, explanation of the table, and explanation of the experiment. 3 paragraphs. It's very clear. I don't know why it's very clear. I hope so. Describe the details of the experiment. Data process setup. Again, we use itemize. We have the feature can be described based on the type of data they refer to. We have the itemize on type of data. You see, before the itemize was on the process, you have the itemize on the type of data. We just do the same. We use the type of data to structure the session. And then we put one sentence at the end, just giving some details. Notice here, session number 3. Session number 3, we didn't think that the structure of the session number 3 was important to have an itemized. Still, if you read in session number 3, like we say, since it was very long, it was 5 subsessions, then at the beginning of session number 5, you said, even if we didn't do itemize, why? Because the itemize before was more important because related to the architecture. This itemize is less important, this organization, because more related to the evaluation. Still, we say, first discuss the performance SML. We then evaluate. Then we saw. So basically, at the beginning of session number 5, we tell you, by the way, guys, we are giving a very long session. This is how we are organizing it, right? So we don't use the itemize because it's not as important as before, because before the organization was on the structure of the solution. Still, we want to help you in reading the evaluation. And then in the evaluation, we just go one by one. And what do? We do the pictures, and then we see to figure 2. If you look at the one, you just explain the picture. And then we do the observation. So section 5.2, 5.1 is first to describe the experiment in detail, then you describe the picture, then you make observations. And the same everywhere. It's not that there is in terms of the reader, right? It's correct. First, I tell what they do. I give you the results, explain the results, and make observation. It's exactly what the reader would expect. 5.2, the same. We describe the experiment, we give some results, and then we make observations. Objective, subjective parliament. Like first paragraph, our aims to learn to predict the ground truth labels. Then it shows the picture, figure number 4, and then we just have to do the observations. Of course, these observations are kind of long, but that's okay. Then the session is finished. 5.4, variability of users. Variability of users, that was interesting. We have a lot of tables, but that was interesting when we realized that there are different types of need users. There are inattentive users, users we don't care. There are predictable users, are the users for which machine learning works, and there are reliable users are the users who do well. The inattentive user, the user will do whatever they want, and the predictable user are the users somehow they don't do perfect, they can be predicted. There was a very important distinction. We made an itemize, and this gave a lot of structure to this page, which was now much clearer to understand. There was the tricksy user also as well, which I think was a guy who was just totally random. And I think all of these, we provide the characterization of user based on how well they were doing. I think you had the 4 tables, right? So I think, anyway, I don't remember how we wrote this paper. Right. Yeah, but you're right. So the first row is an attentive user. The second one is a predictable user. Then the third one is a reliable user. I'm just reading the figure, the comment, the caption, right? And you see in the caption, right, first user, second user, third user, and fourth user. And then we take it back in the structure. There's one-to-one mapping. A reader, even if he doesn't pay much attention, will understand this. And then the observation at the end. At the end, is a conclusive observation if you want to say something, and then you're happy. Right, so number 5, section number 5, we want to do something interesting. So we have a long paragraph. So in order to evaluate, we want to just to evaluate the generality. So we explain why we do this. We explain the motivation for doing this. And then, of course, we do what? Results are showing number 7, second paragraph. We show the results. We give the picture. And then there is no comment here. And then feature work, and then acknowledgement. So you see, I don't know how much I was successful in this exercise. But I want to give an example. First of all, let me say that now I revised the paper with you, but when I started the presentation, I had no memory of what we wrote. This paper, I think we wrote in 2018, 5 years ago. 4 years ago. But the point I'm saying that I could decipher this paper simply by looking at the title, the abstract, the introduction, subsessions, pictures, and algorithms. When I read a paper, myself, when I evaluate the paper, I always do the same. It is not that I read a paper from line 1 onwards. When you get a paper to read or to understand, you should read the paper as I read it in this way. And then you just read the paper exactly as you don't read the paper sequentially, but you read in this way and you write in this way, because this is how different levels of nesting in the structure are provided. And in this way, not only, and if the paper is well written, any of you should write paper so that any reader will read in this way. As you see, what is interesting in a paper by this, if you read it in the usual way, it flows. But when you become expert, and you know how to read papers, just because you know how to write papers, you really exploit in the reading the inner structure. Any paper has an inner structure, like any piece of code has an inner structure, that really provides an argumentation. And when you read it the first time, in particular if you do not know the field, if you're not expert, then you just read in one way, but when you get to read more and more the paper, you understand all these connections that the writer has made. And they are very important for the writer to write, not only because it makes life easier for the reader, but because what I told you now as part of the methodology, if you learn how to do it, it will help you a lot in the writing, not only in the writing, but also in the methodology, how to learn how to write, and ultimately, therefore, in understanding what you work. Because, as I hope you understand now, when you superimpose an argumentation, a structure like the one I've said today, to what you know, clearly this gives a lot of added value, because now you no longer have pieces and bits of different knowledge all in one place or the other, but you're actually able to put everything together in an overall argumentation from beginning to end. And this is exactly why, for the same results, sometimes, quite often, you can write most papers, because the way you write it is going to provide a completely different view of what you've done. So with this, I think I'm done with the example. I hope this is usable for you and is useful. And I would stop here for today. Luckily, we ended up being a little faster.